Alright, so let's take a look at double displacement reactions looking at acid-base neutralization. This is another common type of double displacement reaction that you're going to see. So in acid-base neutralization, you've got a mixture of an acid with a base. So remember, we said that we could find acids fairly easily because the proton is the cation. So when H is the cation, this equals the acid. So H plus is the acid. Whoops. Sorry, bumped you guys away. So H plus is the acid. Then we also said that when we have compounds that have the hydroxide anion, this is the anion, and it is going to also act as the base, OH minus. So that's how we recognize when we have an acid or a base present. So this is a way to recognize an acid-base neutralization reaction. You're mixing an acid with a base, and what you're going to have is the double displacement again. So the cations are going to switch places. So the potassium is now going to switch places with that hydrogen. And so we're going to draw the correct molecular formulas first. So our H is going to come over here with the OH. And you can see that's a nice familiar compound. We usually see this written as H2O. But it's okay in these equations to write it as HOH and think about it as being more of an ionic compound here. It's very close to being one. Its electronegativity difference is 1.4. So it's a very polar molecule, and sometimes it does act as an acid or base under certain circumstances. So now we've got water formed, and the other component's going to be the potassium with the nitrate. Okay, so the first step in this reaction too is when we do the double displacement. So we do the double displacement and we swap the cations. You need to make sure that you write the correct molecular formulas. So you got to write the correct molecular formulas. So we know based on, so again, you're going to use your ionic periodic table. This is our handy dandy periodic table. We know our H has a +1 charge, very easy. Nitrate, we can look up on our table again. We know that's a -1 charge, so that guy's balanced. The OH hydroxide ion is also a -1 charge. Where are you? You're right there. -1. And we know potassium is in group 1, so it's got to be a +1. So we can go to the other side of the equation, and we can say our hydrogen is +1, our OH is -1, and so our H2O molecule is fine. And this actually becomes a covalent bond at this point, and it forms the liquid state. Our potassium is +1, our nitrate is -1, so this guy is going to be 0, which is one of each. So that guy is the correct molecular formula as well. So once we've written our correct molecular formulas, we've got to make sure that the equations are balanced. And this one was very easy because it is already balanced as well. We've got one OH, one OH, one H, one H, one potassium, one nitrate, one nitrate. So we are set there too. So we've written our balanced equation. So again, acid-base neutralization reactions are easy to recognize. You look for a base being mixed with the acid, and the products on this side are always going to be water plus a salt. So that's how you recognize when you've got double displacement reactions that yield acid-base neutralization. So these guys are even more simple than our precipitation reactions.